I was in at Poundland today, and they're now stocking the other version of well, I was going to say 1 watt LED lamp, but it's 3 watt LED lamp, and it's the candle lamp version. So let's take a look at the lamp, let's try it out, and then take it to bits. So here's the lamp, quite smart I have to say, with its little triangular pyramid in the middle, and the 3 LEDs on each side. Now, the other lamp had also got 9 LEDs, hadn't it? I think it had 9 LEDs arranged in a circle. This one has 3 in each face, so let's light this up. I shall get the power meter plugged in as well. Plug the lamp in, and we'll see what it draws. Quite bright, a very nice warm white. It actually looks quite nice. 2.5 watt, so very similar to the other one then. Okay, let's take it to bits. So, the other globe version was siliconed in. This one is also kind of siliconed in, but yeah, that's the same sort of, not chewy silicon. Actually, it's kind of hard to describe that. It's a wee bit more brittle than the other silicons. So that exposes a little pyramid. How does this come out? It comes out like that, apparently. Ooh, it's metal. It's got these little clips that hold the plastic. Is this going to come apart? Ooh, not really. How do I get that off? Oh, there it goes. Brute force and ignorance. Okay. So it's got an aluminium core in the middle, which is quite impressive, and each of the circuit boards has the 3 LEDs wired in series, and they're aluminium core PCB material. It's not got heatsink compound, but they seem to be pressed. I think they're pressed on. I don't know if they're actually pressed really hard on by this. I wonder if some of the silicon and you know, the white zinc oxide type based heatsink compound would have helped there. Not really sure. Anyway, let's pop that on if I can. How does this go back on again? Does it go on that way? Yes, it does. Well, let's get the circuit board out. It goes together easy enough. And they do seem to be held fairly tight. Okay. Once again, this is a... I should have had the soldering iron on for this already. Once again, the soldering iron, the circuit board is held in by the solder joints at the back, which I suppose it saves space and it also keeps it locked in place. Looks similar circuitry. I'll just wait for the soldering iron to come up to temperature. The soldering iron is currently just about up to temperature. What I'll do after this is, if this is the same circuitry, I'll swap the 220 nanofarad capacitor in and make it lower power, because again, I reckon these are probably going to be running at quite a high temperature because there's not any real means to dissipate the power from them. And if you consider that the power dissipation of 2.5 watts divided by the 9 LEDs, 2.5 divided by 9 LEDs equals, yeah, it's exceeding the rating of these LEDs, their ability to dissipate power properly. So that's the soldering iron up to temperature now. I shall wet this solder with a fresh lead-based solder because it tends to work better. Tends to make a better thermal connection onto lead-free solder if you wet it with a touch of the lead-based stuff. Quite large mass joints though, and the soldering iron's not quite up to temperature yet. And then I'll show you my special technique for removing solder from large objects, which involves holding the soldering iron in your less strong hand, touching, using the hand you can flick with fastest basically, touching it onto the solder joint till it's melted, hold it for a few seconds and then flick, and that clears all the solder off that. There's a chance it may land on you and burn you, but that's a minor technicality. That's a good start. That's got most of the solder off. It might not come off the work surface right enough. Oh, it does. Okay, let's see if we can drag this circuit board out now. Alternately reflow these. Yep, they're moving. And that's it out. Right, so what have we got? Looks like the same arrangement as before. It's got the fuse, well, I say it's a fuse, it's a resistor. Now, was the last one 10 ohm? Let's check that out. (10 ohm). It's got the little resistor going out to the LEDs. (30 ohm was last time, it's 30 ohm again. It's got the resistors across the capacitors, which I won't easily be able to test with this, so I'll just check them out. The last time they were... hold on, I should still have the drawing of the last circuit, which should say redrawing it. Somewhere. Oh, do I honestly get through this many? There we go. So that was the last one. I think it's the same circuit. I'm just going to check those resistors and see if they are 330k. The discharge resistors across both the capacitors. 334, 330k, and the other one is over there. 334, yep, 330k, it's the exact same circuit. And the capacitor, if that's the case, then this capacitor, 220 nano, will be rated, 560 nano. Oh, this one's rated 400 volts. I think. Yeah, because the other one was rated 250 volts. That's an improvement if it is. This capacitor was rated 250 volts and 10 microfarad in the other one. Where is it? Oh, it's underneath, wouldn't it always be? 250 volt, 10 microfarad. Yeah, it's the same circuit. That's interesting enough. So that means that it'd be a good idea to change this capacitor for the 220 nano and reduce its dissipation to over half. So I'm just going to get one. Because I just happen to have a drawer full of these capacitors. So I'm going to desolder this capacitor, because this is the one here that limits the current in each half cycle. And I'm going to just desolder that. I'll wet the solder pads again, because it's probably lead-free solder it's based on. You never know, it might not be. It's supposed to be under these retarded European regulations. So I'm going to reflow those two solder joints with a bit of lead. And then I'm going to try and get that capacitor out. Fumbly, because it's a very small circuit board. So that's one leg out, and that's the other leg out. Okay. And I'm going to use some, I'll get rid of this. I'm going to use some desoldering wick to remove traces of solder off those. The desoldering wick is a flux soaked braid, and when you place the soldering on, it kind of sucks the solder into it and leaves usually a very clean pad. You could use a desoldering pump if you want, but I kind of prefer this because it's very definite. It's not a sort of like it's not got that thing with the desoldering pumps where after several pops and every time you click the button it moves, and it just doesn't seem to quite get the solder off. With the desoldering braid it does, it just sucks everything off. Said Clive meeting some smutty double entendre in the process. Oh, there's quite a lot of solder in that one because it's sharing a pad with a surface mount diode. Oh, it's still sucking the solder from the double solder joint here. There it goes. Okay, let's pop the capacitor in there. I noticed, just dropped that resistor out. That's alright, I can get that back in afterwards. So let's solder this new capacitor in, the 220 nanofarad one. And then we'll try and assemble it into the package. Now, if I recall, with the last time I tried putting it into the other lamp, the globe-shaped lamp, it was quite a nuisance trying to get it into the bayonet cap terminals, but we'll see how that goes with this one. That's one, that's two, and which of these, I think it was this one, was this end was soldered in here, so I'll just reflow that joint and then put some new solder on it. And then crop the leads. Looks good. I might just nudge that because it's the resistor body is so close to the circuit board it's actually propping it up at a slight angle, which I don't really want. That's better. Slight micro adjustment. And I shall clean the solder off the end of that resistor, or at least just flow it along a bit, just to make it sort of a wee bit straighter. Where's the pliers? And I'll just reshape that lead. Okay. It has been modified. Let's see if we can fit this back into the body. So I'm going to ping this again, because there's still one of the holes isn't clear. Now it is. I'll just clean that pad up. Don't really need to clean the pad up, but I'm going to do it anyway. Okay, now this is where I fell down last time trying to get this pressed back in. I notice it's taper shaped, so it sort of all squishes into that. I wonder if it's aimed at different holders as well. Okay. You can see one of them. I don't think the wires come through too easily. I think it's actually quite short. But it's also quite a soft, flexible wire, which doesn't really help much. And it's got a splodge of solder in it, so I'll just reflow that and clean it up. Yeah. Let's try again. That's better. Okay, where's my thicker solder? There it is. And we'll solder these in. The resistor's sticking down a wee bit further, so I'm going to crop it so I don't have to go back over it afterwards. I'd rather just build the solder right over these so it forms a dome. That's the way these bayonet cap holders kind of work. It's a ramp that just slides past a contact. Spring-loaded contacts. Looks pretty good to me. I may have to just nudge that one a tiny bit and just build it up a tad, otherwise it's going to act like a sort of ratchet and stop it rotating in the holder. That looks better. Let that cool down because it's quite a large solder joint. Okay, now how does this actually go in? Does that just stuck? I can see residue of the silicon, so I'll just... oh, that comes out quite easily. Any more? No, that's about it. There are 4 recesses. I think they're just support pillars more than anything else. I don't know if they latch or not. I'll find out when I poke them into it. Okay, that's it. Assembled as far as I can see. It doesn't really hold in by much. I think it's maybe held in by the glued in dome. So I'll put some glue in that afterwards. But in the meantime, I'm going to plug it in and see if it goes bang. One day, one of these will go bang. It's almost inevitable. It might be this one. Who knows? Socket. Is it going to go bang? Is it going to go bang? Is it going to go bang? Let's plug it in and find out. Okay, it didn't go bang. Let's get the power meter on. I plugged it in without the power meter first, in case it did go bang. Shame it's at mains voltage. It'd be quite nice just out like that without the glass over it. Okay, now last time the lamp power reduced to about 1 watt, and this one has reduced to exactly 1 watt as well. So yep, good result. And I'm going to get some just general sort of rubber cement type stuff and I'm going to stick that back in. I'm not going to use silicone, I think I'll just use Evo stick or something like that. Yeah, that looks pretty good. Good result. It has been downgraded and upgraded simultaneously.